All right, so listen up. So now, from the notes that we were actually going over yesterday, I need you guys to actually take a look at those formulas. This problem right here matches one of my formulas. That matches one of the formulas. So I need to make sure I am able to match it up.
A plus B.
So A and B.
Sine plus B. Oh, no,
So
minus.
is it the sine or is it the cosine?
Sine.
It's going to be a sine, right?
Yeah.
So is this one a plus or a minus?
Minus.
So it's going to be a minus. So I'm writing this out now. Sine of 40 minus
160.
so sine of 40 minus 160.
Yeah.
Now, when I get these types of problems like this, what do I need to make sure I do?
Degrees.
Okay, they're in degrees, right? Okay. So I need to make sure that I put these in correctly. And so when I match up my sine to go along with this, because this is from my formulas from yesterday, so these, I can put them. They're not on my unit circle, but now I can actually do the math. So let's do this math right here. So sine of negative 120. Now, is negative 120 on my unit circle?
No.
No. So I have to find the what?
Coterminal.
Excellent, excellent. Coterminal, that's what I'm looking for. Coterminal. I need the coterminal. So negative 120, and what am I going to do to that?
Add 360.
Add 360, very good. So I'm adding 360. So negative 120 plus 360 gives me
240.
240. Now, sine 240 is 240 on my unit circle.
Yes.
Yes, I know you guys all have that out there in front of you right now, right?
Yes.
So, sine is the y value at 240. So my answer is
Negative rad 3 over 2.
very good. Negative rad 3 over 2. Hey, look, I circled it, so that one must be my answer.
You put the sign in there.
Nope, because it's asking for the sine of that.
Alright.
Wait, that's that half? Oh, never mind.
Okay, let's take a look at this next problem. So now, in this next example, I'm actually going to make some, I'm going to move this over to a different slide so you guys could actually do this. This one doesn't have enough room, so I'm going to do this right here. So write an expression involving the functions of theta. Okay, so I have sine of 30 plus theta. All right. Now, my A value is what?
30.
30. My B value is,
Theta.
so I need to go ahead and find that out in my thing. So I need to break this up to actually use the formula that was given yesterday. Sine 30, what goes next?
Cosine.
Cosine
Theta.
theta,
Plus
cosine, right? This is from my formula.
Yeah,
I'm just filling it in. Now, I take a look at my unit circle. I need some values from that unit circle. What is the sine at 30?
1/2.
Times cosine of theta plus, what is the cosine at 30?
Rad 3 over 2.
Times sine theta. And since I'm multiplying those numbers together, those numbers times the sine and cosine right there, what's my common denominator going to be?
2.
So they're both going to have a common denominator too, right?
Yes.
So can I just combine all that?
Yes.
Okay, so 1 times cosine, so it's cosine theta plus rad 3 sine theta all over,
2.
there we go.
Edit.
Yeah.
Yeah,
Oh wait, sorry, my bad. Woo. Almost forgot that.
that's a pretty good circle.
Okay. Okay, now let's take a look at, what was the next one? 5, 4 right here, right? Yes.
Tan 45 degrees.
Okay, so tan 45 degrees minus theta. Okay, tangent is one of those ones that are just a pain. They are. They are what they are. Got to deal with it. Sometimes you just have to work with tangent. Now, I'm going to break this up to be the parts. My A is 45, my B is theta. So it's going to be the tan 45. What symbol goes here? Minus tan theta over 1 plus, very good, tan 45 times tan theta. Now, I'm going to go off to the side, and I'm going to do my fraction, because tangent is a fraction, isn't it?
Yes.
It is sine over cosine. So I'm going to go over here, break that up. So I know tan 45. Okay, it's going to be sine over cosine. What is the sine at 45?
Rad 2 over 2.
Rad 2 over 2 divided by,
Rad 2 over 2.
hey wait,
That's 1.
it's 1. Why is it 1?
Because they're both, yeah.
Both the same. Same on top, same on bottom.
Yeah.
So the whole thing will cancel, so I'm left with 1. Very good. So I'm going to have 1 here. So every place that I see tan 45, I'm going to replace it with
1.
very good. So now this is going to turn into 1. Very good. Over 1, 1 times.
Why don't you just do the
I'm going to. I'm just plugging in right now so we can see this. Right now. 1 times tan theta. It just tan theta, right?
Yeah.
1 times anything gets that self, right?
Yeah.
So do I need that 1 right there?
No.
No, I don't need it. I don't need it. It's just kind of confusing at this point. Let's do that multiplication. So my final answer, 1 minus tan over, and what do I do now? Say circle it. Are you okay here?
Yeah.
It's not too bad. Not too bad. Okay, so let's take a look. So I'm going to make a clean one for my next one. So the last one is going to be, yeah.
Only 2 formulas for that. Like, you know what I mean?
Yeah, that's all we have for right now. I'm going to throw more at you, but I'm only doing a little piece at a time.
Yeah.
So sine of 180 minus theta. So sine of 180 minus theta. Okay, so I have to go dig out the formula for sine, right?
Yeah.
There's a minus sign in between, so that means it's going to be sine 180, right? Because my A is 180 and my B is theta. Cosine. Okay, I know, it didn't come out very well. Cosine theta minus. Like that, right? Questions before I go on, because I am kind of going at this quickly. But this is all stuff we've done. We've done the stuff, now we're just doing it differently. So for this problem right here, I'm going to take my unit circle and I'm looking at 180. What is the sine value at 180? 0. Times cosine theta minus, what is cosine at 180? Very good. -1 times sine theta. anything times 0 is
0.
good. So the left side go away. Now, minus a negative gives me
Positive.
positive. Very good. So I just get a positive sine theta. What goes next?
Square.
Say circle it.
Circle that.
Sorry, put a square around it? What's wrong with you?
I've been squaring.
Huh? You've been squaring it?
I thought a square.
Yes, that guy.
Why did the cosine go away again?
Okay, cosine times 0.
Okay.
There we go. Alright, so we're back to here. So we get all my answers. It's on the other page. Now, this one is the interesting one.
Oh.
But it's not bad.
That's a formula book?
I will tell you right now, we've already done this.
Really? Out into the world.
We've already done this.
Never seen no books.
I guarantee we've already done this. So I'm just going to show you it now. But we already did this. We did it back first semester. So I'm going to start off with this piece right here. And I'm going to ask you for this information here momentarily when I go to my next slide. Now, it gave me what? So it was sine
Sine A equals 4 over 5, comma, pi over 2,
pi over 2
Yeah.
greater than.
less than a less than pi, right?
Yeah.
Okay. Now, we've done this already, but now we're doing it exactly the same again, but in a different unit. I already showed you guys how to do this back first semester. We have two angles that we're trying to do. We have, if you notice right here, I'm looking for sine of A plus B. So from my formula, I need to know sine A cosine A, right? And I need to know sine B cosine B, right? Given this information right here, you know that the y is what?
The
4. R is, and x is,
unknown.
I don't know yet. This information over here off to the side says that A has to be between pi over 2 and pi. Look at your unit circle. Pi over 2 to pi. Put your finger over on pi over 2 and trace it over to pi. What quadrant's that?
2.
Very good. In quadrant 2, what do you know about the x value?
Negative.
Negative. And the y value has to be?
Positive.
Very good. That's what we just got out of this. We know that because of this information right here, that this is going to be a negative. How would I find the missing side here? Very good, Pythagorean theorem. So I'm going to use Pythagorean theorem here. So it's going to be x squared plus 4 squared equals 5 squared. Okay, keep going, right? Keep going. X squared plus 16 equals 25. That is a 3, 4, 5. Very good. You did see it, right?
X equals 3.
We're going to have a whole bunch of these, and we're going to use a lot of Pythagorean triples. It's actually referred to as the Pythagorean triple. So subtract 16. X squared is 9x equals plus or minus square root of 9. So now, when we're dealing with quadrants, we have possibilities of both. Now, we already said at the very beginning that the x value has to be negative, right?
Yes.
Okay, so now my answer is going to be x is negative 3. Right? Because square root of 9 is just 3. Alright, we're good. We got my x, y's, and r's. That's what I needed
We're done?
with that piece right there. Now we have a b value. Let's go back to my... So I'm going to make a new slide, and I'm going to ask you guys for this information right now. My b value, look, just to break it up, look, I'm even going to change colors on you guys here. Woo! Man, right here. I need this information right here, and this is going to be for my b. So I'm going to break it up. So now, It said sine or cosine? Was it
Cosine B
equals
negative 5/15.
5 over 13, right?
Yeah.
And it said it was from where to where?
Pi B 3 pi over 2.
Now, on my unit circle, put my finger on pi and trace it over to 3 pi over 2.
It's in the third one.
Pi, trace it over to 3 pi over 2. It's quadrant 3, isn't it?
Yeah.
Okay, that's what I needed. I needed to know that because it is in that quadrant. So what does that tell me about the y value?
Negative.
Very good. So, given this one, I know that x is, r is, y is, don't know yet, but it's going to be a negative, isn't it? Okay. So, again with my Pythagorean theorem, right? Negative 5 squared plus y squared equals 13 squared. Again, if you notice it, this is another triple. 25 plus y squared equals 169. Subtract 25 from both sides. Y squared is equal to 144. Y equals plus or minus square root 144. And again, we said it's in quadrant 3, right?
Yes.
Okay. Y is negative 12. Very good.
Also, it's alright.
Now, we have X, Y's, and R's for B now, don't we?
Yes.
Okay. So do we have X, Y's, and R's for your A?
Yes.
Okay, so I have everything I need. So this is going to be exactly the same as what we've been doing, but instead of finding our values from the unit circle, I'm going to find the values from what I just made. So instead of going to the unit circle to find whatever fractions to plug in, I'm going to plug these in instead. Let's see how that works out. So I'm trying to find sine of A plus B. Was it A plus B or A minus B? A plus B. So my formula, write it out. Sine A cosine B plus,
Cosine A, sine
right? Yes.
I don't know.
Now, for this one right here, to find the sine of A, I go to my notes where I did A's. I did all my A's. Sine is what over what? Y over R. So for this first one right here, change it back to red. So for this one right here, it's going to be what? Sine was 4 over 5? Okay. 4 over 5. Now for this next one right here, we have to go to the B's. What is cosine? What was it? Negative?
Negative 5 over 50.
Okay. So the next one is a plus sign, right?
Yes.
Cosine of A sine of B, negative 12 over 13. So instead of finding these on the unit circle, I'm now finding them because they gave me the information to plug these in. So let's go ahead and do this. So now when I multiply fractions, I multiply straight across, right?
Yeah.
Okay, so that's going to give me what?
Negative 20.
Negative 20 over what? Very good. Now, look right here. I got a negative negative, so that's going to be?
Positive.
So positive. So it's plus a positive. Very good. So plus, positive. Do they have a common denominator?
Yes.
So my answer is 16 over
65.
65. Now, what do I need to do?
Simplify.
Say circle it. It's not going to simplify.
I know.
Okay. You got me there. We did. Woo. All right. Anyway.
Is that a question?
So let's take a look. Was that my all of them? Okay, I did sine of AB. Now next one's tangent, right? So now I have to use tangent of the same thing.
Yeah.
What did you mean?
That was just sine.
That was just a sine, right? But no, look. Okay. For this one
I
right.
thought that we were doing one.
Okay, look.
I thought we just did sine, tangent, and.
No. Look, we haven't done tangent yet. Now, but
No,
for look right here,
I'm fine.
we did all the work. Okay, we did all the work at the beginning now. So the rest we just fill in numbers. All our work comes from this right here, the blue and the red. And now from there, we're just filling in numbers. So next thing I'm looking for is tangent AB.
Can you go to like the first slide around?
This one?
No, the one where we did.
This one?
Yeah. I have it written down.
Okay. Alright. So we said what? Tangent next?
Yeah.
Oh, where's this right this?
Tangent of, is it A plus B?
A plus B.
Okay. Now, this is going to be a whole lot easier than the notes. Because we're not going to have a big complicated thing. We know that tangent is a ratio of what over what? Y over X. So do I need to even worry about the R's here? No, I just need the Y's and the X's, right? Okay. So it's gonna clean up a lot. So my formula, tan A plus, right? Tan over
1 minus
Would you write down the formula, right?
Yep, that's just the formula.
Is that a multiply?
Yes, that's a multiplication because where it says tan A, tan B, there's no operator in between there. So that implies that those two things are being multiplied.
Oh.
Alright.
It's almost like two parentheses being up against each other like that. So you have like an open and a closed right back to back. So that's why. It means that it's a multiplication. Now, let's go to A. Go to A. So now tangent of A is y over x. So the y value on A was what? 4 over my x was? Okay, so I'm going to put that there. Plus tangent of B is negative 12 over negative 5. Okay, negative 12. I'm going to write it out for this case. Negative 5. But what happens when I have two negatives? It cancels out, becomes a positive, right? A negative over a negative is a positive. So I'm changing that right now so I don't confuse myself later. All that's going to be over 1 minus. So right here, I'm going to bring in my negative 4 over 3 times. Do I need to include the negative thing again?
No.
I know it's just going to be 12 over 5, right?
Yes.
Okay.
Does it cancel?
Now, from right here, this goes back to when I was dealing with my fractions. The bottom is a binomial. So it cannot multiply by the reciprocal. What was the other way to clean up a fraction over fraction? Okay, conjugate is only for radicals. Multiply by the...
Reciprocal.
No, I can't do that because that only works when I have one term right here. Common denominator. Do you guys remember that? The common denominator?
Not really, but okay.
What's the common denominator of the whole thing? 15. It is going to be 15. So I'm going to multiply top and bottom. I'm going to multiply top and bottom by 15. So I'm going to have to distribute this. Alright, did I lose you guys here, or are you guys still ready?
It's alright.
Okay,
Wait,
so
that's only with tan.
this is the tan problem. It is kind of complicated, but I'm telling you, the common denominator thing
I
is,
know that, but that's the time we do that with is only with tan.
You could do it with a lot of other problems too.
Alright.
Okay, but we're looking at it like this. These two terms right here, this is going to give me one fraction, and this is this. There's two terms in the denominator. So because there are two terms in the denominator, to clean that up, I'm going to multiply the whole thing by the common denominator.
Yeah.
The common denominator, so it's only 3's and 5's here, right? Only 3's and 5's. So the common denominator in between 3 and 5 is 15. Okay, whenever I have a binomial like this, you can multiply by that and it's going to cancel it all out. It's going to cancel out all your denominators, basically. As I distribute here, when I distribute to over here, so when I distribute to here, one thing a lot of people don't realize, fractions are two different operations. You would multiply by the top and divide by the bottom. So the bottom is the division, the top is a multiplication. It's always like that. But now when I'm actually looking at this, to simplify, I'm going to show you guys how to simplify before we actually do the math. So simplify before the math. So now, as I'm distributing here, what is 15 divided by 3? 5. So it's 5 times the negative 4? Negative 20.
Wait. Did we do that?
So 5 divided by 3,
It's 5.
or I'm sorry, 15 divided by 3 was 5,
Uh-huh.
and there's still that negative to deal with, right?
Yes.
So it's negative 4 times what was left over.
Oh, okay, I see that.
Okay? Since I only canceled out a 3 of that, so I get this. Now let's see if it still works over here. But now when I do it over here, 15 divided by 5,
3.
3 times 12,
36.
36. Positive or negative?
Positive.
Like that.
Alright.
So that's my numerator now. It just cleaned up a whole lot, didn't it?
Yeah.
Okay, so now when I distribute over here to that, 15 times the 1, way over here, keeps going right there.
15.
Just 15, right? Okay. 15. Now when I distribute here, what's the denominator of these two fractions? Since they're being multiplied together right here anyway,
15.
it's 15. So what's going to happen to my 15 divided by 15?
1.
1. Okay. So what's going to be left now? The negative 4 times the 12. So since I have a negative 48, it's minus negative 48, right? So minus negative 48. So it's going to become a positive 48. Plus 48.
Where did you get 48?
Where did I get 48? You ready? Okay, so now, Oshki, I'm going to show you this, but I'm going to clean this up a little bit before I do my distribution. Let's see if that helps you out. Okay, so now on this right here, these two, let's multiply these two before I can do anything. This would be a negative 48 over 15, right?
Yes.
And what am I multiplying that by?
15.
Right?
You
Be-
just did that, but you didn't do it to the top.
Oh, okay, watch.
Can you do it to the top too?
It's happening. It's all happening.
Yeah.
Okay, so I'm worried. Okay, are you understanding that this right here is
I
negative?
understand that, but
Okay, so when I distribute this, the reason why that this one looks a little bit more complicated because I had two things here, and it canceled out all of the bottom, right?
oh, never mind, because you multiplied it.
Yeah, when I multiply these.
Alright.
So now 15 divided by 15 is 1
Yeah.
times negative 48 gives me the negative 48. But since I have a minus negative 48 gave me plus 48.
Yeah.
Did that help out?
Yeah, I got it.
Okay,
It was
so
just because I thought that one was the bottom was a plus, but it's just a plus.
oh, okay, all right, there we go. So we got it now. Now can I actually put those together?
Yes.
Okay, I can put those together. So what do I get here?
16 and 63.
Circle.
Will that reduce? No, it won't.
We'll leave it.
Not too bad.
Yeah.
What do you mean not too bad?
It's not.
It's time consuming. It's gotta go slow.
Exactly. But we did all the work at the very beginning for all of this. Now, let's go back. So this is positive, right?
Yeah.
This tangent is positive. Okay. So let's go back to this. What is the quadrant of this? So I know the tangent of both of these is a positive. Where is tangent positive?
Where to be first quadrant?
It's quadrant 1 and
Quadrant.
isn't it quadrant 3?
Oh yeah.
Two negatives make a positive, don't they?
Yeah.
Okay, so it could be 1 and 3, right? That's good. I know the tangent was positive, so it's there. So now we're doing some elimination here. So the sine of a plus b, okay, let's take a look. Sine, let's go back a page. Sine of a plus b was, that, is this positive? Okay, so let's take a look. So for this right here, sine is positive. So where is sine positive at? 1. Anywhere else?
2.
Y values. 1 and 2. 1 and 2. If you look at the y values on your unit circle, just look at the y values. Okay? It's 1 and 2. Okay. So where do you think the quadrant of both those together is going to end up at?
1.
Very good. It's quadrant 1. Why do I know it's quadrant 1?
Because they both have 1.
Because that's where they overlap, don't they? That's where they overlap. So I know it has to be in quadrant 1.
So you did all that just to find this?
It is a lot of work, but it's stuff we've done. We're just plugging in for what we have now.
Is this coming out?
So for right here, do I need this one? There's 3, 3, 3, 3, 3. There we go. All right. So we're done with that one. So we're going to work on example 3 on Monday. Or I'm sorry, example 4 on Monday. Don't forget. Nope. Don't forget, like and subscribe, right?
Oh, we recorded the whole